Okay, we did do this in class, but I'm just going to go over it again. It's exercise 5F, question 5E, to prove that 1 plus x to the power of n times 1 plus 1 on x to the power of n equals this. We're going to start with the left-hand side. 1 plus x to the power of n times 1 plus 1 on x to the power of n is... Now what I'm doing, I'm keeping the first thing the same, 1 plus x to the n. And what I'm doing on the right-hand side is that I'm writing it, taking out 1 on x, so I'm taking out 1 on x, so 1 on x times x is 1, and 1 on x times 1 is 1 on x. So I've broken the 1 plus 1 on x up into 1 on x times x plus 1 to the power of n. Now if all of that is to the power of n, then the 1 on x is to the power of n, and the x plus 1 is to the power of n. Now 1 plus x to the n is the same as x plus 1 to the n, so bases here are the same, so we can add the n's. So these two become 1 plus x to the n plus n times 1 on x to the power of n is 1 on x to the n plus n is 2n. So writing this first, we've got 1 on x to the n times 1 plus x to the 2n, which happens to equal our right-hand side. Now I think that's the easiest way to prove that, so we're not going to try another method with that, because I have tried a couple and don't seem to get anywhere with them. Now it says now by the next part of the question says, by equating coefficients of 1 on x, prove, so give an alternative proof to the resulting part D, but the resulting part D is the following. So prove that n choose 0 times n choose 1 plus n choose 1 times n choose 2 plus n choose 2 times n choose 3 plus all the way up to n choose n minus 1 times n choose n is equal to, sorry, bit off the screen. So by equating coefficients of 1 on x in those above expansions, prove that this over here is equal to 2n factorial over n minus 1 factorial times n plus 1 factorial. Okay, we're going to do that. So we've got 1 plus x to the n times 1 plus 1 on x to the n is equal to 1 on x to the n, 1 plus x to the 2n. So we're starting with that, and we're going to equate coefficients of 1 on x on both sides. Okay, let's expand this left-hand side. So the left-hand side is 1 plus x to the n times 1 plus 1 on x to the n, which is n choose 0 plus n choose 1 x plus n choose 2 x squared plus n choose, second last term, n choose n minus 1 x to the n minus 1 plus n choose n x to the n. That's the expansion of 1 plus x to the n. The expansion of 1 plus 1 on x to the n is n choose 0 plus n choose 1 times 1 on x plus n choose 2 times 1 on x squared. Second last term is n choose n minus 1, 1 on x to the n minus 1. And the last term is n choose n, 1 on x to the n. So that's the left-hand side. Now I'm looking at the term in 1 on x is. Now the term in 1 on x, I would have to do n choose 0 times n choose 1, 1 on x. Actually, I might do that on the next line. So term in 1 on x is n choose 0 times n choose 1, 1 on x. The next term in 1 on x would be n choose 1x times n choose 2, 1 on x squared. So n choose 1x times n choose 2, 1 on x squared. The next term would be n choose 2x squared times n choose, we would have the next term here would be n choose 3, 1 on x cubed, plus, we would keep going. Let's look at, if we want 1 on x, we need the top power to be 1 smaller than the bottom power. So the last term would be this one, n choose n minus 1 x to the n minus 1 times n choose n, 1 on x to the n. So that's the term in 1 on x, and so therefore the coefficient of 1 on x would be just n choose 0 times n choose 1. We know that when we put x on x squared here, we get 1 on x, plus the next term would be n choose 1 times n choose 2. Here, x squared over x3 is 1 on x. Next term, n choose 2 times n choose 3 plus the last term would be n choose n minus 1 times n choose n. Now, because if you put x to the n minus 1, 1 power less than, which is 1 power less than x to the n, you do end up with 1 on x. So that's the coefficient of 1 on x on the left-hand side. Now the coefficient of 1 on x, sorry, I'll just look at the term. So term in 1 on x on the right-hand side, which is this. Actually, what I'll do with the right-hand side, I'm just going to put right-hand side equals, not term in 1 on x. And I'm just going to expand that right-hand side. So therefore, the right-hand side is 1 on x to the n, 2n choose 0 plus 2n choose 1x plus 2n choose 2x squared all the way up to 2n choose 2n minus 1, x to the n minus 1. And the last term would be, so I've just started with what the right-hand side is. I've expanded the right-hand side, 2n choose 2n x to the 2n. Now I'm looking for the term. So the term in 1 on x is going to be, well, it must be, there would be a term in the middle. I'm just going to insert a few more terms in the middle. The way we're going to get 1 on x is going to be 1 on x to the n times, we're going to have the x to the n minus 1 term. Actually, this is a 2n minus 1 here, by the way, so just fix that. That's a 2n minus 1. But somewhere in the middle, I need to insert 2 more terms. So 2n choose n, x to the n is a term, but I actually need the term before that. So I'm going to put the term before that. 2n choose n minus 1 times n to the n, x to the n minus 1. The one after that would be 2n choose n, x to the n. So the way I'm going to get the term in 1 on x is multiply this 1 on x to the n by this 2n choose n minus 1 x to the n minus 1. That will give me the term in 1 on x. So just going back here, just please insert these two in the middle of that, okay? Now, if I look at this, 1 on x to the n times that, I get 2n choose n minus 1. I get x to the n minus 1. Sorry, I'm off the page. So if I multiply this by that, I get 2n choose n minus 1, x to the n minus 1 over x to the n, which is 2n choose 1 times 1 on x. Okay? So therefore, so just going to the next page. The coefficient of 1 on x on the right hand side is this 2n choose, sorry, that's n minus 1. So 2n choose n minus 1. Now 2n choose n minus 1, sorry, I just wrote that incorrectly from that row to that one. So this is 2n choose n minus 1. Actually, I'll just rewrite it here. So I had that is equal to 2n choose n minus 1, 1 on x. Sorry, I just sort of ran out of room up there. So therefore the coefficient of the 1 on x is 2n choose n minus 1, which happens to be 2n factorial over 2n minus n minus 1 factorial times n minus 1 factorial, according to the definition of NCR, okay? Because remember that NCR is n factorial over n minus r factorial times r factorial. So I'm just using that here, which happens to be 2n factorial over 2n minus n minus negative 1 is 2n plus 1. 2n plus 1, sorry, 2n minus n is n. So 2n minus n is n minus negative 1, or minus 1 is plus 1. So it's n plus 1 factorial times n minus 1 factorial. And therefore, we've proven the result, because we look back now at the coefficient on the left-hand side, coefficient of 1 on x on the left-hand side is that expression, and it equals this. So therefore, we've proven the result. So therefore, n choose 0 times n choose 1, plus n choose 1 times n choose 2, plus n choose 2 times n choose 3, plus n choose n minus 1 times n choose n is equal to 2n factorial over n plus 1 factorial times n minus 1 factorial. Okay, that's the end of question 5E. So we've proven we've provided an alternative proof for the result in D. Now for question 6A. Okay, question 6A. By equating coefficients of 1 on x to the power of 4 in this expansion, prove this result here. So let's have a look. We've got 1 plus 1 on x to the power of 4 times 1 minus 1 on x to the power of 4 equals 1 minus 1 on x squared to the power of 4. Let's look at the left-hand side. Term in, actually I'll just expand. So left-hand side is 1, sorry, I'm just going to expand. We've got 4 choose 0 plus 4 choose 1, 1 on x, plus 4 choose 2, 1 on x squared, plus 4 choose 3, 1 on x cubed, plus 4 choose 0, 4 choose 2, 1, 1 on x, 4 choose 2, 1 on x squared, 4 choose 3, 1 on x cubed, plus 4 choose 4, 1 on x to the 4, times, here we've got 4 choose 0. Now this will be times 4 choose plus 4 choose 1, 1 times negative 1 on x, so we go minus. So instead of going 4 choose 1 times negative 1 on x, we'll just put the minus out the front. The next one will be 4 choose 2 times negative 1 on x squared, which gives us a plus here, so we get 1 on x squared, minus 4 choose 3, 1 on x cubed, plus 4 choose 4, 1 on x to the power of 4. Now that's what the left-hand side is. And so therefore, we're looking at, so the terms in 1 on x to the 4 will be, so we're looking at the terms in 1 on x to the 4, it will be 4 choose 0 times 4 choose 4, 1 on x to the 4, plus you'll have you'll also have this next one, 4 choose 1, 1 on x times negative 4 choose 3, 1 on x cubed. Then we'll have 4 choose 2, 1 on x squared times 4 choose 2, 1 on x squared. Then we'll have plus 4 choose 3 times negative 4. So we've got this one, 4 choose 3, 1 on x cubed times negative 4 choose 1, 1 on x. Then we'll have these two, plus 4 choose 4, 1 on x to the 4 times 4 choose 0. So they're the terms in x to the 1 on x to the 4. So therefore the coefficient of 1 on x to the 4 is 4 choose 0 times 4 choose 4 plus 4 choose 1 times 4 choose 3. Oh, sorry, this will be minus negative. So it'll be minus 4 choose 1 times 4 choose 3. Then we've got plus 4 choose 2 times 4 choose 2. Then we've got another minus. So we get minus 4 choose 3 times 4 choose 1. Then we get plus 4 choose 4 times 4 choose 0. Now let's look at the question. Notice there are squares here, 4 choose 0 squared, 4 choose 1 squared, etc. Or minus 4 choose 1 squared. Now we can say, but 4 choose 0 equals 4 choose 4. 4 choose 1 equals 4 choose 3. So therefore, that is equal to 4 choose 0 times 4 choose 0 minus 4 choose 1 times 4 choose 1 plus 4 choose 2 times 4 choose 2 minus 4 choose 3 times 4 choose 3 plus 4 choose 4 times 4 choose 4, which happens to be 4 choose 0 squared minus 4 choose 1 squared. I mean, you can go straight from that to this row. You don't have to include this middle one. plus 4 choose 2 squared plus 4, sorry, minus 4 choose 3 squared, that's a minus, plus 4 choose 4 squared. That left-hand side is done. So question 6, we've done the left-hand side. Now we need looking at the right-hand side. So the right-hand side is 1 minus 1 on x squared to the power of 4. I'm going to expand that. And that is 4 choose 0. Remember, with a minus, you go plus minus. So it'll be minus 4 choose 1, 1 on x squared, because this is to the power of 1. Then we'll get plus 4 choose 2, 1 on x squared to the power of 2. Now, I just want the term in x to the 4. If I go with the next term, etc., minus 4 choose 3, 1 on x squared cubed, I end up with 1 on x to the 6th term. And then the last term will be plus 4 choose 4, 1 on x squared to the 4. Now that gives me the term in x to the 8. So I really don't need these last two terms, so I can just go minus dot dot dot, or you can include them both. So the term, so therefore the term in 1 on x to the 4 is this one here, is 4 choose 2, 1 on x squared squared. So therefore the coefficient, of term in 1 on x to the 4 is 4 choose 2. And so therefore you can just write your conclusion, okay? So therefore you just write that all of this, so all of that equals this 4 choose 2. Okay, I'm not going to write it all out. You can write that all out. So therefore that equals that. Now that's question 6a. Says to generalize this result and prove it by considering this expansion. So generalizing this result would be for a power, if we compare that and this, we'd be doing it for the power of 2n as opposed to the power of 4, and we'll be equating coefficients of 1 on x to the 2n. Okay, so by considering this, generalize that result. So we are going to consider coefficients of 1 over, so this is what we are going to do. We are going to be considering coefficients of 1 on x to the 2n to do this. Okay? Okay, let's start. The left-hand side is 1 plus 1 on x to the 2n times 1 minus 1 on x to the 2n, which happens to be 2n choose 0 plus 2n choose 1, 1 on x, plus 2n choose 2, 1 on x squared, plus, keep going, 2n choose 2n minus 1, 1 on x to the 2n minus 1, plus 2n choose 2n, 1 on x to the 2n. So we'd have that times 2n choose 0, because this is 1 minus 1 on x, we have the same expansion but with alternating positives and negatives. So plus, then we go minus 2n choose 1, 1 on x, plus 2n choose 2, 1 on x squared, plus dot 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 dot. The second last term will be the negative, minus, sorry, that's a minus. So this here is a minus up there. So this is plus dot 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 and then minus there, okay? So sorry, no, that's plus. That's plus because that's the positive one, sorry. This is my minus here. So plus dot dot dot. Second last term is minus. 2n choose 2n minus 1, 1 over x to the 2n minus 1. And my last term will be positive. 2n choose 2n, 1 on x to the 2n. Okay, so that is both of those expanded. Sorry, this is a plus. I'm really sorry about that. So therefore, the term in 1 on x to the 2n will be, it'll be this first one here times the last one there. So it'll be 2n choose 0 times 2n choose 2n, 1 on x to the 2n. The next term will be this one here, but it'll be a minus because it's a positive times a negative. we'll have 2n choose 1, 1 on x times 2n choose 2n minus 1, 1 on x to the 2n minus 1. Because x times x to the 2n minus 1 bases are the same, this is x to the 1, so you get 2n minus 1 plus 1 is 2n. So this here gives you a term in 1 on x to the 2n. This is my first term in 1 on x to the 2n. Plus the next term would be 2n choose 2, this one. 1 on x squared times the second last one in this, but I'm actually not going to do that. What I'll do the second last one here, 2n choose 2n minus 1, x to the 2n minus 1, times the second one here. So this will be a minus as well. 2n choose 1, 1 on x, and the last term will be these two multiplied by each other. So it'll be 2n choose 2n, 1 on x to the 2n times 2n choose 0. So we've got a whole heap of dots in between. Okay, so I've just got the first two and the last two terms. So therefore, the coefficient in 1 on x to the 2n, so the coefficient, so that was the term, coefficient in 1 on x to the 2n will be 2n choose 0 times 2n choose 2n minus 2n choose 1 times 2n choose 2n minus 1 plus ... Then we've got minus, I'll do the last two. 2n choose 2n minus 1, 2n choose 1, and the last one is plus 2n choose 2n times 2n choose 0. Hopefully you can just see that. But we know that 2n choose 0 equals 2n choose 2n. 2n choose 1 equals 2n choose 2n minus 1, and so on. So therefore, coefficient in 1 on x to the 2n will be 2n choose 0 squared minus 2n choose 1 squared plus all the way up to the second last one will be 2n choose 2n minus 1 squared, and the last one will be 2n choose 2n squared. Sorry, I just got these other sheets under here. Okay, so that's our left-hand side. Let's look at our right-hand side. So the right-hand side equals, so coefficient of 1 on x to the 2n on that left-hand side is that. So the right-hand side is just 1 minus 1 on x squared to the 2n. Now, I'll just start expanding that, which would be 2n choose 0 minus 2n choose 1, 1 on x squared. Remember, I'm looking for the term in x to the 2n, plus 2n choose 2, 1 on x squared squared, which would be 1 on x to the 4. Now, the way I'm going to get, then I'd have minus, I'll just keep going, 2n choose 3, 1 on x squared cubed, which would be 1 on x to the 6. I'm just going to go plus ... The way I'm going to get the term in 1 on x, looking for the term in 1 on x to the 2n, it must be 2n choose n, 1 on x to the 2n, because notice I've got, for example, 2n choose 3, 1 on x to the 6. This x power is double this. This x power here, x to the 4, is double that too. The x squared is double the 1. So therefore, that's not the last term, right? But it is one of the terms in between, okay? The very last term would be 2n choose 2n, 1 on x to the 2n squared, which would be 4n. So I don't want that last term. That's a plus for the last term. But this one is somewhere in between. It's this one. So therefore the coefficient, of the 1 on x to the 2n term is 2n choose n. So therefore we can say that 2n choose n is equal to 2n choose 0 squared. So coefficient of x to the 2n term on the right hand side is that. Coefficient of 1 on x to the 2n on the left hand side is this. So therefore 2n choose n equals 2n choose 0 squared minus 2n choose 1 squared plus etc. minus 2n choose 2n minus 1 squared plus 2n choose 2n squared. Okay. Now it says to check it with for n equals 4, 5 and 6. I might just check it for n equals say 4. Okay, so if I check it for n equals 4, I get left hand side is 8 choose 4, which happens to be 70, and the right hand side would be 8 choose 0 squared plus 8 choose 1 squared. Remember, I've got to go all the way up to 8 choose 8 squared. Sorry, it's plus, sorry, then it's minus, then it's 8 choose 2 squared minus 8 choose 3 squared plus 8 choose 4 squared minus 8 choose 5 squared plus 8 choose 6 squared minus 8 choose 7 squared plus 8 choose 8 squared. Now we do know that all right, 8 choose 0 is 1, so we get 1 squared, minus 8 choose 1 is 8, so we get 8 squared, which is 64. 8 choose 2 happens to be 28, so that's 28 squared. Then we've got 8 choose 3, which happens to be 56 squared, plus 8 choose 4 is 70 squared, but 8 choose 5 is the same as 8 choose 3, so we'll get minus 56 squared again. 8 choose 6 is the same as 8 choose 2, which is plus 28 squared. 8 choose 7 is the same as 8 choose 1, so we get minus 64, which was 8 squared. And the last one's plus 1, because 8 choose 8 is 1, or 1 squared. And so therefore, if you evaluate all that on a calculator, you do get 70, which equals the left-hand side, and so therefore we can verify that result, okay? Just showing you that. Now that's the end of question 6.